An electron has a rest mass of 0.511 MeV. We've sped it up so that its mass is dilated to this much, right? Now, this is actually a very simple problem. We're going to solve it the same way we do the other ones. But let me just point something out here. This is just the coolest thing about kinetic energy here, right? Is how much kinetic energy does this have? Well, it's the difference in mass, right? The difference here is 1.511 minus 0.511. The kinetic energy is 1.00 MeV, right? So this electron has a kinetic energy of 1 million electron volts. That's why its mass is 1 million electron volts more than the rest mass, because where did the mass come from? It came from kinetic energy. Now, the coolest thing is that if we had a particle accelerator, this would be an electron that we accelerated through 1 times 10 to the 6th volts. Okay, if we accelerate an electron through 1 times 10 to the 6 volts, it's got an energy of 1 million electron volts. So this, on the face of it, it looks like a very complicated problem, but we end up solving it by subtracting and adding and stuff like that. Okay, so now let's just go ahead and solve this thing, right? The velocity is going to be c times the square root of 1 minus small squared over big squared, right? And so that's going to be c times the square root of 1 minus and 0.511. We've almost tripled this thing's mass, right? 1.511, and that's squared, right? I'm not even going to throw in the 3 times 10 to the 8th. I'm just going to flat out calculate it in terms of c. So square root, left parenthesis, 1 minus, left parenthesis, 0.511 divided by 1.511. That thing squared. And then another right parenthesis for the end of the square root, right? Okay, here we go. 0.941079. Obviously, well, we have 3 sig figs, so we'd have to say 0.941C.